Okay, so we're going to look at the Junior Certificate Higher Level Maths Paper 2 for 2019, questions 3 and 4. So question 3, the coordinate diagram below shows the screen of a digital clock at 1500 hours at 3 o'clock in the afternoon here. The images P, Q, S and T of this screen under 4 transformations are as follows. So you've got the object here and you've got 4 images here. P, Q, S and T. So what we've got to do here is complete the table below to match each image to the transformation that produced it. Use each letter P, Q, S and T only once. So you've got to write those in here. So axial symmetry in the x-axis is the first one. So if we take axial symmetry in the x-axis, that means we're going from here up to here. So what would that look like? Well, the 1 here would just remain as 1. That would reflect here as 1. Over here you would end up with something that looks like this. I would imagine something like that. If you imagine that reflecting up here, your 2 dots here would remain the same and the 2 zeros would remain the same as well. So it's like a 1200 if you like. So that would be image S here, image S. So let's just write that in here. So axial symmetry in the x-axis is the first one, S here. Okay. Axial symmetry in the y-axis. So let's have a look at what would happen there. So this is our y-axis here. So we want to reflect this object over here. So what would that look like? Let's see, the 1 would just remain as 1. That's not really going to change. Then, actually let me do that a little bit more vertically, so it's something like this. Then we would end up with something cross like this, down, cross, down, and over like this. So you imagine this is the most difficult one to do, this 5 here. The 2 dots will remain the same here, but the 2 zeros will end up over here somewhere. So we would end up with something that looks like this. So which one is that? That's actually T here. That's this one here, T. So here we have T. Next one is a translation. So which one is a translation? So let's see, a translation is it's actually not going to change the orientation of each of these at all. So it's actually going to be P here. P is the translation. It's exactly the same as this. So the third one then is just P. So this is P. And then central symmetry in the origin 0, 0. Central symmetry in the origin. Now you're not required to draw these. You're only required to work out which one is which. But I'm just going to draw them anyway. The 1 will remain. This is the origin here, so we're going to do central symmetry in the origin. So you'll end up with a 1 here. Now the 5 then is going to look like it's going to look something like this, I think. Let's see. It's going to be over, up, something like that. And then you'll have your 2 dots as well, and then your 2 zeros as well. So that's actually Q. So that's Q here. Okay, so that's that one done really. That's question 3. Let's have a look at question 4 here. The diagram below shows the center circle of a soccer pitch. So you got your center circle, and this is a line going through it, and this is the center of the pitch here. The center of the circle is marked. At the start of the game, Gary and the referee stand at 2 points on the circle G and R. So this is where Gary is, and this is where the referee is here, as shown. Okay. Now, Jorg stands at the point J on the circle. So Jorg here is standing somewhere around here on the circle, so that the angle at the referee is 90 degrees. In other words, the angle J or G is 90 degrees. So in other words, there's an angle here of 90 degrees between Gary, the referee, and Jorg somewhere. So there's a 90 degree angle here. Using only a straight edge, construct the point J on the diagram above, label the point J. So what you're going to do, I'm doing this freehand, you guys have got to use a straight edge, a ruler or something like that. So really what you're going to do is put your ruler on these 2 points here, join them up. Actually, maybe I'll just do this in a different color here. So you're just going to join these up. So you're going to start here, you're going to cross here and continue it on until it hits the circle. So that's really where jorg is going to be. So we're going to label that J. So in other words, if I connect this up to here and Gary up to the referee here, you can see this is actually an angle in a semicircle, so it's going to be right angled here. So that's really your construction, because we're only using a straight edge, so there are no arcs or anything like that. State a theorem or corollary that justifies your construction in part A. So the theorem, well, there's a theorem and a corollary really, and the theorems are let me see, it's this one here actually. The angle at the center of a circle standing on a given arc is twice the angle at any point of a circle standing on the same arc. It's theorem number 19 here actually. Now the angle at the center of a circle standing on a given arc is twice the angle at any point of a circle standing on the same arc. Now really the one that we're looking at is a corollary of that, and it's corollary number 3 here. It's each angle in a semicircle is a right angle. So it's really this theorem and its corollary number 3. So the angle at a center of a circle standing on a given arc is twice the angle at any point of the circle standing on the same arc. So let me just write that out. By the way, as I say earlier, I just showed you this. This is from my website, malloymaths.com. You can download that other sheet from here. It shows you all the theorems, axioms and corollaries that are required. And here, this just gives you a list of constructions. Anyway, let's just write that out. The theorem was theorem number 19. You don't have to worry about the number, but it's what way do they state it here? Let me just read it again. The angle at the center of a circle. So it's the, let me write that in white. The angle at the center of a circle is twice the angle on the circle, I think they say, is it? Let me see. The angle at the center of a circle standing on a given arc is twice the angle at the circle, or on the circle we should probably say. Standing on the same arc. Now you could even draw a little sketch here. You're probably not required to go into this much detail, but if you have a circle and you have, oops, let me just go back here a little bit. So you have this kind of thing here. That should be, let me just go back again. That's still not quite right. Okay, you get the idea anyway. Look, this is the center here. So this angle here will be twice this angle here. So this is the angle at the center, and this is going to be the angle at the circle, and they're both standing on this arc here. So the angle at the center is twice the angle at the circle standing on the same arc. Now the corollary of that is this one here. Each angle in a semicircle is a right angle. So that just means, so you can write that down as well. Each angle in a semicircle is a right angle. So that's a corollary of this. In other words, if you have a circle and you have the semicircle here, so this is the center here, any angle here in this circle here is going to be, in the semicircle, is going to be a right angle, because this here is 180 degrees here. So, and they're both standing on this arc here, both angles at the center and at the circle itself and at the center, they're both standing on this arc here. So if this is 180 degrees, this must be 90 degrees here, and that would be a corollary of this theorem up here. So that's stating the theorem or a corollary that justifies your construction. So we've done both here really. Okay, so that's it for those two questions.